These projects are designed to cultivate multiple skill sets that complement a series of videos created for the purpose of acquiring a foundational knowledge of the Python programming language. These projects will cover coding both console-based and GUI applications. Tkinter is a Python binding to the TK-GUI toolkit, and its framework is built into Python's standard library, so it does not require the installation of any additional modules. This makes Tkinter a convenient choice for building graphical interfaces for Python applications. All source code in these videos is available at the 1byte@a-time GitHub repository. You will find a link to the code used in each video beneath it, in its description and comments section. You may use these links to download the source code.
This is a meatier, more beefy Python project. It's a role-playing game, RPG, and it's about, what have we got here? 6,270 lines of code. Okay, and so up here. You could theme this any way you want. I sort of did a cutesy MLP type theme, but you could do science fiction, Dead Space, government agent, Rainbow Six type scenario, fantasy, Dungeons and Dragons, whatever. You could theme it however you like it. But I designed this project to be a fun project because it's a game and hopefully will keep you motivated, but also to go over every single basic Python object, foundational Python component that we will be learning in this series of upcoming videos, and every Tkinter widget and component and event handler and listener and so forth. Okay, so let's take a look at the interface if we run it.
The Python Tkinter GUI.
All right, so we have some basic menu items here, and this is just opens up a child window from the parent window, as well as help opens a child window from the parent window. We have cheat, and we have load and save game. And I also have some buttons down here. Again, in the final version, you'd probably get rid of these, or you wouldn't make them so easily accessible to the player. But when you're building a game, you want to incorporate an easy way to cheat, sort of a God mode. So it makes it easy to test and modify and build onto the game by having that capability, so that you can basically run around and do things without getting killed. So this just shows where all the items are on the map, the NPCs, the traps, the combat type situations, the spells, the magic items, and so forth. And then there's cheat mode here. All right, so they need to build a character, so let's go ahead and build a character. Plays a sound on a thread. Let's build a unicorn. So we have a class hierarchy, and we're going to instantiate a class object. We build a unicorn. It's thundering outside. Choose a gender. It's a beautiful girl pony. Yay! Let's choose a name. All right. Let's say Carly. And here are my opening stats. Click go to continue. Now we've got to make the NPCs. The NPCs are created, and these are some of the conversational components and arrays and list objects. We'll be able to interact with them and speak with them and so forth. I click go. Here's my basic map. I've got some navigation buttons now that they're enabled. Notice that I can travel around my map, and here's text-based output if I want to go into the mountains. Exit the mountains. Go east. If I want to go, let's go to the swamps of sadness. Okay, I'm just going to exit. Let's go around the map and find some items. Will I try one of the blueberry cupcakes? Yes or no? Let's do yes. Oh, found a magic sigil. Cool. So I can change that. So my weapon, I have a weapon now. I can use the sigil. All right. If I go back there, that's the spot where I formerly found the sigil, but it is no longer there. Now here, scrumptious strawberry cupcakes. Well, I got a good thing with the blueberry cupcake. Let's try a strawberry cupcake. I do, but oh no, I take a bite. It was deliciously sweet, but I lost 10 health. It was a poison cupcake. And see, it subtracted it from my health there. Okay, and then if I go back that's where that trap was. And that's where that sigil was, the weapon item that I found. Look around. Sure. Do I dare? Yes, I dare. Ooh, I get lightning, the magic ability of lightning. And same thing. Look around, nothing there. Look around, nothing there. Go up here, look around, nothing there. Look around here. Let's grab that. Okay. Now Ice Blast. Let's go up here. Look around, look around. Ah, yes. Okay, there we go. Let's go up here. Let's go up here. Ooh, yes. Okay. All right. Let's go here. Oh, look, we find a store. Let's buy some items here at our store. Okay. So, let's get a grooming brush. And I want to get a slingshot. And I want to get some slingshot pellets. Because a slingshot's not much good without slingshot pellets, right? I have 0. So I buy 10. My money's still good. 2,970 down here. I'm going to buy some more pellets. 20. And more pellets. 30. I still have plenty of money. Let's see what else have we got. I'm going to buy a rope. And some climbing cleats. And a torch. A magic fairy torch. And I'll buy a couple of healing potions. They might come in handy, right? And again, the player would never really start out with this much money. But so now, and if I use a healing potion, what happens? If I click, I use a healing potion, it restores 100 health. So watch my health meter here, right? And my healing potions goes down, and my health is going up, all right, by 100. So, and then I've lost all my healing potions. Let's look around the store, and let's exit. Okay, so those are all the inventory items that I have. And let's go, let's see, let's go over here. We'll go to Celestia's Palace. Oops. And here I am, here's my first NPC encounter. Madriga Stafila. Madriga Stafila, what can I do? Let's speak with Madriga Stafila. So I'll choose S. And why do today what you can put off until tomorrow? And let's speak again. A stitch in time saves 9. Okay? Speak again. Madriga Stafila turns to you and says, I have a headache. All right, what if I choose to conversate? I'll conversate. Input what you'd like to say below. How is the weather? How's the weather? And I submit it. Enter C and click go to continue. Really? What about how is the weather? Click go to continue. Okay, so that NPC might drop some clues, but I'm gonna go ahead and leave that NPC for now. I'll look around Celestia's Palace. And I'm gonna exit. Okay, and I'm gonna go ahead and save. All right, and when I do that, notice I'm in E3. Look at my inventory items here, right? So when I do that, what happens? I'm gonna go ahead and close the game. Let's look in the folder in the directory. So it created two files. One saves my character in the game, and one saves the game state. And these are just collections of integers, strings, and booleans, okay, that get saved to the character file and the game state file. So now that we've saved a file, let's relaunch the game and let's load our game. So to load a saved game, I just need to type in the name of my game, which is right here in the middle between the prefix and the postfix file extension for the character file and the game state file. So it's just Carly in this instance. Enter character and game state name you want after the prefix and before the .ext, then click load to load them. All right, so I've got my name in there. I'm going to click load, and when I do, these are all the items that get loaded. Again, maximum verbosity, and then I click go to resume my game. And when I do, notice I'm at the location I was when I saved. There's E3. Here's all my inventory items, and all my abilities have been saved in my stats and so forth, just as they were. All right, so let's save and load. Let's cheat and run God mode. So we'll get into God mode here, and I'm going to choose a slingshot, and I'm going to choose telekinesis. And I'm going to go over here, and in this case, I run into a slime mold, and I'll choose to do combat or do battle with it. It moves menacingly towards me. Uh, Teach this slime mold a lesson through combat, or will I walk away? Well, yeah, I could walk away and live to fight another day, but no, but it's okay. I have God mode enabled, and it's only a slime mold, right? Why should I be worried? So yes, let's fight. Okay, so in this case, we flip a coin. I'm lucky. Luck favors me. I get the first attack. I click go. Here are the opening stats, and then it's going to go ahead and launch a combat loop. It's just going through and calculating random attack values and adding in things like combat experience, subtracting the opponent's defense capability to defend or block the damage that I'm dealing to them. It's taken and factoring in the magic ability I'm using, telekinesis, along with my slingshot. Slime mold defends. Whether or not invisibility was activated, or if it was capable of invisibility for that particular character object. And then subtracting the defense capability. And after all, attack and defense moves, in this case, preventing negative values, and then basically defeated the slime mold. So click go to continue. And then if I go back there, let's go back to that location. And then I see ooey gooey remains of an icky slime mold that I formerly defeated. All right, so saving a file, loading a file, cheat mode, navigation, just some basic things in our interface, playing sounds, showing images. Those are some of the things that we'll need.
The Python Tkinter code.
So let's step through the code for this project. And again, to play sounds, you're going to need to install the play sound module, pip it in. And you don't want the latest, greatest, most recent one, because using it, it's just been buggy. Sometimes it doesn't work at all. So what you want to do is if you haven't installed PlaySound already, make sure that you specify version 1.2.2. It's more, that one's a stable version. Actually works better than the newer one. If you've already installed it, just uninstall PlaySound and then pip install, reinstall it, PlaySound, and then evaluates to version 1.2.2. And that will get you what you need to be able to play like WAV files, MP3 files in your projects in Visual Studio with Python. So our imports, basically we need an instance of Tkinter as TK, and message box for message box, image TK and image for images, resizing, anti-aliasing, OS to get the relative path to the directory our script is running in so we can load media files, sounds, images, and so forth. Play sound to play our MP3s and our WAV files. Threading, because remember when you do a Tkinter graphical interface, all those widgets run inside of main loop and they listen for events and triggers inside main loop. So if you do something like play a sound, a video file, show an image, go through a loop, use some type of repetition structure or loop process, it will lock up your graphical interface and the end user, the player, won't be able to interact with it uh, until that process finishes or that sound quits playing or that loop iterates to the very end. So to prevent your GUIs from locking up, you need to start implementing multi-threading. And then each process you'll launch in a separate thread. You don't want it to run inside the same thread that main loop is running in, so it doesn't lock up your interface. Time for date and time functionality, and random to give our game some randomness. So here we have some GUI globals that we use to manipulate the main parent window from which all the child windows are spawned. And we need to get an instance of the toolkit, Tkinter. Okay, and we're going to do tk.tk. And we're instantiating, this is basically calling the constructor for the toolkit, the Tkinter toolkit, and assigning it to window. And window, it's actually more than a variable. It acts like a pointer in C++. Even though you don't have those in Python, under the hood, it acts like a C++ pointer. So it now points to that object in memory, and now we can use it to manipulate, to send data to and get data from that object. Okay, set the title of the window, the main parent frame, the width and the height in these variables, and then we're going to use window, which we set up here to point to the instance we built of the toolkit. We're going to call these special methods, winfo screen width, winfo screen height, and that'll return the width and height of the screen. You see, when coding the project, we don't know what resolution the end user is going to be running when they run our program. So this makes it a bit more dynamic. Instead of hard coding a value, we'll get the screen width, we'll get the screen height, okay? And then in this case, we're going to take our desired, 1060 by 765. We're going to take screen width and subtract window width, and screen height and subtract window height, and divide by 2, and a bit of a regular expression here. And then up here in the middle, we're going to use the geometry method to set it to that variable. So that'll cause it to appear in the middle of the screen. Resizable, in this case, false for width and height, because we use absolute positioning for our GUI, for our interface. And so we want to turn off resizing because it hasn't been coded to, absolute positioning gives you a lot more control over where you place widgets on your frames and your windows. So that's the upside. But the downside is it doesn't deal so well with resizing. So in this case, we've turned that off. Okay, so we set the background with configure. And then here, we're basically, GUI is a variable and it's initialized to null or none. But again, there are no pointers in Python. But if you are familiar with C++, this acts like a pointer. It's sitting there. It's inert. It's not doing anything. Points to none, to null. But we'll use that later. And when we instantiate our GUI, which we're going to define inside of a class, within a class, when we build that object from that class blueprint, we'll assign it to GUI. We'll use GUI as the handle to get data to and retrieve data from that object, which will become our main frame, our parent window. And we'll scroll all the way down here, and you'll see how that works. All right, so GUI was none, but we're going to say GUI is equal, and then RPG GUI. Here we're calling the constructor. We're instantiating the RPG underscore GUI class, which is the class we define our graphical interface in, all of our TK enter widgets and main frames. And notice as the parameter, as an argument to the constructor, we pass in window, which that's the pointer that points to, our instance of TK, the TK enter toolkit. And then we call main loop as you would with any TK enter, method. So let's go take a look at that. So GUI points to this, and this is our blueprint for our class, okay? And we set up an image directory and a sound directory. And we use get current working directory to get the relative path to subdirectories for images and sounds for the game. And this just makes it relative to wherever the directory the script is running from. So it makes our code a little bit less breakable. It's certainly not unbreakable. There's a lot of ways to break this, but if we used an absolute path and then people were to modify it or move things around, say I just typed in C:\\/ blah 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 blah. Well, then it would be less resilient to modification, less resilient to change. So we're just using this method with the OS module that we imported to make our code more dynamic, to make it able to deal better with change, with modification. Okay, for our variable, we're going to set up some symbolic constants, and these will be used in a method called switchboard. And this just determines, the locations as the player travels our level 1 map. These could all just be literal, numbers, integers, but that's not very human friendly. I would look at the number 14 or the number 7 or the number 24, and I wouldn't know offhand the location. But if I set up symbolic constants, then I can say, okay, well, level 1, center 1, level 1, south 1, level 1, west 2, level 1, east 3, and so forth. So that's all we're doing here is just setting up symbolic constants, okay? Choice, that just holds some of the player's, decisions, can be used for navigation, can be used for equipping and finding inventory items, can be used for all sorts of things. Location, which we'll use in a method we'll define later called switchboard. And that's how the player will walk around the game. They'll keep calling switchboard. And we set up paging variables. And again, using a GUI is very different from console programming, okay? A graphical interface requires event-based programming. All these widgets are on an interface, and they're all running inside of a loop, and they're all listening for triggers, for events. And when those triggers happen, and that event is detected, it goes and calls a corresponding event handler method or function, okay? So you have to think of how the end user, how the player will interact with your interface. You have to think of every time they click this button, the same thing will happen. Unless you code your functions to deal with that, unless you code your functions to deal with, to be able to do different things based on the number of clicks or make them contextually sensitive. So if the player's in this set of conditions and they click the button, this happens. But if they're in this set of conditions and they click the button, that happens. If they click the button 1 time, 2 times, 3 times, different things happen. Well, you have to think of all the logic for that. And so I call these paging variables, but I use these in different dialogues in the game. So when the player's clicking through building their character object, or when they're talking to an NPC, getting clues, when they're going to the store and buying some inventory items, I use these for dialogue and for paging inside of methods, and then I can just increment it, and they click a button, and when that thing happens, and then when that event is complete, they click the button again, and then after I've incremented it, another part of that method will execute. And then I can decrement to make the player go back, say for validation. They don't enter a valid uh, input that I'm looking for, gender for their character or the class, alicorn, unicorn, Pegasus, whatever. Well, I can decrement and increment to page up and page down in those functions and in those methods. So these are I just call paging variables, okay? These are environment combat variables, and willing to fight, there's a magic ability the player can gain called friendship cast. And if they cast friendship, then their opponents lose their willingness to fight. They want to be friendly, sit around and chat, and they don't feel like combat. So that's just, it's a string value here, but I could have also used a Boolean value for that. I did examples of both in this project. These are environment variables, okay? As the player goes through the game and they do different things, they're going to have combat and fight different creatures. And when they do, if they go back to that location, if they've defeated that opponent, they shouldn't have to fight that opponent all over again. So how will our project, how will our game remember what they've done, who they conquered, who they fought, traps they've sprung? In this case, we were using Booleans and strings to keep track of that data. And then we'll code decision structures. And so if they engaged in combat with this particular opponent, and if they survived and they won, when they go back, they'll see a carcass. They won't see that opponent alive again. So we have to keep track of all those things. And that's here, these environment combat variables, okay? And it's the same thing for, the first time they come to a location, they see one thing. But if they return to that location later in the game, they see something different. And so we're using these as game state or environment variables to track what the player has and has not done. We have to keep track of all that. We have to remember all these events. So these values have to be stored and then later written to a file when they save the game. And then when they load the game, all these values have to be read from the file. And then all of these, environment variables, game state variables have to be initialized with the values from the file. So that's what's happening here. Map inventory event variables. Okay, now there's two sets for every inventory item and every magic ability. There's two sets of variables. Outside of the entity class, the player class or the opponent, there are these game state environment variables. Did they find the staff at a certain location? No. Well, then if they go to that location, they find the staff. But then if they come back to that location, Freudian slip. If they come back to that location, they can't find it again. So we have to set these booleans to true, and that way we can remember, when they go back to a certain location on the map after they've already taken an item, then they don't find it a second time. Same thing for these magic abilities here. Now, this set of data, the game state data, is totally separate from their inventory, how they equip and use their inventory for equipment and for magic skills. That is inside the class, defined in the class itself, the entity class. But it takes two sets of variables, one set for game state, another set for the player's actual inventory, what they have, what they found, skills they've acquired. Okay? We'll go over those in the class definition, but healing potions that they found. Again, if they find a healing potion, add it to their inventory, we have to set the environment variable to be true. Otherwise, it would be, they could just keep going and getting infinite healing potions. We have to turn that off. So when they go back, they see just an empty room or an empty box where formerly there was a healing potion that they added to their inventory. Okay. In this case, our NPCs are globals, whether or not they've encountered them. And then we can do different things. So the first time they meet the NPC, and then they go back and the next time they meet the NPC. Okay? Whether or not they've encountered traps. All those are environment variables or booleans that we need to keep track of things. Okay? Now, let's go and look at our interface. So these variables here we're using for our list boxes. And in this case, from our entry, our TK entry widget. and our list box widgets that we add to our window. And these string variables we'll use to get input from those objects. We're going to preload a bunch of images. All right, so these are the map images, the wolf that displays at the beginning in Discord, um, and then other images here, Celestia's Palace, Underground, the mountain cabin, mountain inside shop where the store was, where they could buy inventory items. And this is just a global to hold input from child frames and windows from the parent. These act as pointers as well. Player heroine and player opponent. They're initialized to null, to none, Python's version of null. And current player is nobody. And we'll use that inside of a combat function that activates an attack sequence that will use allow the player to use their magic skills and their magic items and equipment that they bought or found in the game, and they'll be able to do that. But in this case, this will be used in that function to control the flow of combat. And then our NPCs, we haven't created them yet. We haven't built them yet. Okay. These are our sounds, and all of our sounds have to be played in separate threads. So we can't just come right out and call play sound, because if we do, it's going to lock up our GUI and it'll stop responding. So what we do is we call this method. For every sound we want to play, we call the thread method that we wrote, and then inside that thread method, we call play sound, and then we launch it in a separate thread. All right, so I call this method from this method, and it actually calls play sound and plays my MP3. And that way, it keeps our GUI responsive. So we do that for all of our sounds here. Okay, these are just helper methods or functions I wrote. Things work a bit different with widgets and a Tkinter application. With the text box, things don't refresh like you think they would. And to simplify things, instead of having to type 3 lines of code or 2 or 4 lines of code, depending on what I want to do, I wrote these methods to help. So if I want to dramatically cause text to appear and pause and wait a certain number of seconds, I wrote this method. And it takes the special self attribute. Most methods will that are defined inside of a class, the number of seconds and a string, the message. And it just uses the update method on the window and after. And again, this has the effect of refreshing the interface and allowing us to see what's happening even though we are pausing. All right. So it's not, with the console, it's easy. You could just sleep, but you can't do that with a Tkinter app. So dramatic pause append will wait the specified number of seconds passed down as an argument and then display that string. Dramatic pause write will replace the text rather than appending. It'll erase everything there and replace it. But it still has that dramatic pause, all right? That, basically it will pause and then the number of seconds, okay? So that's using update and after. We have to do that with a Tkinter. We can't just use a simple sleep method because the behavior wouldn't function properly with our Tkinter windows and frames. And then we have text append and text write, and this just does that without the dramatic pause. But again, I didn't want to have to type all that code every single time I wanted to either display text with a pause or directly or append or write over. So I created these 4 helper methods here just to save me some time. Okay, all nav buttons disable. And here we're just disabling the navigation buttons. And in context, in different places in the game, we'll disable them all or enable them all to prevent the player from, running away from a fight that they can't run away from. Or when they're doing something that, they have to complete that task before they're allowed to leave or to navigate in the game or before they start the game. So there are reasons we want to, either enable or disable the navigation buttons in the game. So that's all buttons disable, all buttons enable. Here is our navigation engine. It's basically this function or this method called switchboard. It takes the self attribute and it uses all our symbolic constants. So whenever, and we have a global variable we pass around, an attribute, well, it's in our class, but it's global as a data member within that class. Not truly global, I guess, um, but whatever we do with that, the value of location that's inside of our GUI class, it calls the corresponding function or method. And this is how they move around the game. As we manipulate and modify and change the value of location, it's going to go call all these different functions that respond to our symbolic constants. And then based on that, it's going to change the images, change the map, play different sounds, display text, offer items, inventory, traps, combat, NPCs to talk to, whatever. But this method here is central to the whole game. It's how they navigate back and forth in the game. And by manipulating the value of location and setting it to any of these symbolic constants here, it will then call the corresponding function or method. And that's how they walk around in the game. Navigate action. In this case, there's a default sound. But remember, we never call playSound directly. We start a new thread, and then we call playSound in that new thread, and then our interface stays responsive. All right, and we're going to call switchboard. And switchboard is just going to take a look at location and say, hey, what's the value of location? Whatever it is, we're going to go call the corresponding function or method. And then here, because to sort of be conservative, we recycle or reuse choice for many different things. Navigation and picking up an inventory item, buying things from the store, speaking and talking with an NPC. So based on the way the game is coded, I have to invalidate when there's a navigation action, and I do that by setting choice to a special character. All right, so in this case, the number sign. And then just to make it more convenient, on our TK entry object widget, I'm going to set the focus every time they navigate. And that way if they want to run through the game real quick, they don't have to constantly change focus and move the mouse as much. It just makes it a bit more convenient by setting focus on it. Introduction. All right, when the game first starts, it's going to show them this. And then in this case, location would be set to call this method, right? So again, if location is set to L1 intro, level 1 intro, it calls the introduction function. And until we change the value of location, it'll keep calling it. But if and only if they enter Y in that TK entry widget, then we're going to change the value of location to need to create character. And we call switchboard. And that automatically will call this function. And what happens if they need to create a character? If that's the value of location, it calls the create character method. See? These are functions to initialize the character and initialize the game. But here's the next important thing that we do, where we're building or instantiating a character. Here in create character, they're going to instantiate any of 5 classes of object that we give them choices for. So valid input options would be 1 through 5, okay? And we're going to call the initialize character method. And here's where we're using our paging variables. So, the first time we call create character, the paging variable is 1. This happens. The next time, it's 2. And then this happens. And so output, input. All right, output, input. It just toggles back and forth. We're displaying things to the player, getting information from the player. And then we have to validate it too and make sure that it's okay. So they can choose any of 5 classes of object. If they do, we take our pointer to the player heroine, and we're going to call the constructor and build or instantiate one of 5 classes we've defined: alicorn, unicorn, pegasus, princess, or pony. And we also have to do a little bit of validation here. What if they didn't enter anything? Or if they entered something that wasn't 1 through 5? some gobbledygook. Well, we have to provide a way to deal with that. And so that's what our else is. We have if and elif, but our else here is to catch whatever is not. And if it's just some nonsense, not the values we're looking for, 1 through 5, we decrement our paging variable and it goes back 2. Well, every time this function is called, it increments the paging variable. So to move the player back to the previous dialog, we have to actually decrement and subtract 2, decrement twice in this case. And we're going to call display entity once we build whatever character that we build. If it's not null or not none, then they gave us valid input. And we'll call display entity on that object. But we have to check for that with another decision structure, because if it is null, we can't call display entity on a class of object that doesn't exist, that was never instantiated or never built. That would cause our program to crash, right? Okay, so once they've decided on a class of character to build from our inheritance hierarchy, we let them choose a gender. And once we do, again, we're validating. It has to be valid. They have choices 1 through 3. I don't know. I just added that in. I thought I was trying to be funny, but hey, whatever. In this case, okay, so here we go down, and then if they've chosen a valid option, we display what they've chosen, and we display the stats, display entity, okay? Again, if they choose an invalid option, we decrement twice and send them back to the previous dialog, okay? Now choose a name for their character, and that string value comes in, and then we have to set it. We keep incrementing or decrementing our paging variable to move them up and down between dialogues in this method, okay? Please choose a name, and we need to get the input, and then in this case, they incremented it, they entered the name, and they clicked go. So we need to get that text, and then as long as if choice is not equal to null, make sure that they actually did enter a name, we say, hey, whatever they typed, that's a lovely name. And we use our pointer to our entity object, or, be it an alicorn, a unicorn, whatever, to set the value of entity name to choice, and choice is what came in from our entry widget, all right, our TK entry widget there. Otherwise, if it's null, hey, that's an invalid name. You have to type at least something for a legitimate name. And again, we decrement twice to page them back up, or we increment once every time we call the method to advance them through the dialog and page them down. And I use this technique in multiple functions. So with a paging variable, you can control dialog with your TK enter GUI, okay? And then the rest of these are all functions. And based on the value of location, switchboard directs the player to these different functions. And then there's a north and a south and an east and a west, right? And then if they find something, if they, in this case, if choice is 0 or 1 and found staff is false, they haven't found the staff yet, they can acquire the staff, okay? And this displays the scenery. And I do the same all the way down. We'll go through all these methods, all these functions here a bit. These are just carefully constructed decision structures that have to flow in the game as they navigate or walk through the game, okay? And scrolling and scrolling and scrolling. All right, so all of these work with switchboard, and you can step through the code, and this video is going to be way too long as it is. So grab the code from GitHub if you want to walk through it, and you can see how the logic flows, how the logic works, okay? These are some other locations that switchboard will call or invoke based on the value of location. Discord's lair, Friendship Forest, Pegasus Citadel, the mountain of meanness, swamp of sadness, unicorn junction, hills of happiness, slime mold encounter. Now these are different from just standard navigation locations. These involve combat, okay? So when we get down, down here, they work like a navigation function would work with switchboard. Still depends on the value of location, and switchboard would still call these functions based on whatever the value of location was, but we have to code these a bit differently. Um, Again, we have to sort of use paging. So I have to use our paging variables and count up and down the dialog. And we're going to do the same thing, right? We're every time we call the method, we'll increment by 1. But if we have to move the player backwards, we'll decrement twice. Otherwise, automatically we increment each time. Okay? So that's how that works. And then for every combat item, all right, basically the logic or the idea is pretty much the same. So we're going to give them a choice to either engage in combat, they can fight, or they can turn tail and run away. And we're going to detect or look for a Y or an N, a yes or a no. And if it's not a yes or a no, the choice is invalid. And we'll ask them again. Okay? And that's where this decrement here, we're decrementing twice, it moves them back up to the previous dialogue and that function and that method. Very different logic from console programming. See, it sort of changes the way you have to think about things when you code. And then based on that, if they choose combat, we're going to build an antagonist. So this is sort of a just-in-time build. And that way it saves resources. They can play the game, and the game won't consume as much memory or waste as much resources because we don't build an antagonist, an opponent, unless they actually choose to engage in combat. Then we'll instantiate it and it'll consume memory and resources and it'll exist. But it actually doesn't exist until they choose to combat or fight it. And we could sort of get metaphysical here with like quantum mechanics. Um, they say that, the universe only exists because something observes it. Well, well, maybe we're all in a simulation then, because it's just more efficient that way. We don't need an antagonist. It doesn't have to exist until the player actually observes it, and then we instantiate it or build it. Ooh, who would have thought that we could get into quantum mechanics and metaphysics just by talking about Python? But who knows? Maybe our universe is like that. Maybe we're in a giant simulation, and maybe until we actually observe a tree, the tree's not there. And maybe it's just in time, it's instantiated instantly, and it consumes resources, and the atoms that make it up are there as we observe it. Who knows? But even if it's not that way in real life, it's that way in our Python project because that's how we coded it to save some memory. Okay? So we instantiate, we build that object, and then once we've built that object, uh, they've chosen to fight. So we're going to call switchboard, and um, in this case, we're going to go call a combat method. All right. So location, combat location is set to whatever the current location is, because if they survive and they finish combat, we need to hold this value so that we can return them back to whatever location they came from in the map. And then we set location to be combat sequence. And then that causes switchboard to go call the combat method. Okay. And these all work the same way. All right. So all of our combat methods, harpy encounter, dolphin encounter, yes or no, do you want to engage or not? Do you want to fight or run? If you do, you build the antagonist. Once you build the antagonist, you need to store the value, wherever they came from in combat location. So if they survive, we can send them back there. And then we set the location to combat sequence. In combat sequence, that's going to go call our combat method, pony combat. Okay? Discord boss encounter. Logic works the same way though. We're using our paging variables to increment and decrement to move the user up or down in our dialogue based on what they do and the input that comes in. Multiple opponents encounter. This is just to code a list or an array of objects. Just to provide an example of using an iterable. So we're going to build 3 dragons and we'll hold them inside of a Python list or an array. And then in the combat sequence, the player has to fight all 3 of them at one time. Just did that to show you how you would, code that as an example. Get player input is a method or function that allows the player to type in a string, it launches a child window from the parent window, takes whatever they type in as a string, and then returns it and stores it in a variable that the NPCs can use in their conversation methods. So they can take that string the player types in and parse it. And based on the value, they can say different things to the player, or maybe drop hints or clues based on what the player asked them. But this is just the interface part where it launches the child window, and it has to have a submit button handler, and we add a submit button, and there's an entry object for them to type their text, and a label. Just a very simple child window, okay? NPC 1 encounter. All right, here's our first NPC. And in this case, describes what's going on. NPC 2 encounter, okay? And then NPC 3 encounter. And that'll lead and direct the player in their conversations with the NPCs. Display combat stats. This is just a textual way to visualize the attributes of the player and the opponent. We can call it from combat. Pony combat. Now here's our combat sequence, and within this function, we're going to call the attack method inside of the classes that we've defined. And there's 2. There's pony combat when the player fights a single opponent, and then we had to code a different one, pony combat multiple, for our list, our array. Remember those 3 dragons we instantiated? Well, when we build them and we load them into a list or an array, this method, combat method, has to be coded to deal with an entire array or list of multiple antagonists or objects that the player is engaging in combat with. Okay? So what happens in the single combat method? Well, again, we have paging variables, and based on the value, we move them down the dialogue, or we decrement to move them back up the dialogue. Okay? So first we're going to flip a coin, and that's just a bit of randomness between 1 and 2, heads or tails. And if heads, hey, heroine. And if tails, hey, antagonist. So it adds an element of luck to who gets, to attack first. Just a little bit of randomness there. Displays that for the player, displays their combat stats, okay? And then here we have to have some decision structures. If the opponent entity health and player entity health is greater than 0, both of those, and willing to fight is true, we haven't, done a friendship cast and made that false, then and only then can we keep fighting. If either the player has died or the antagonist, the opponent, or the player has died, can't fight anymore. No more combat. And if friendship cast has been invoked, again, no more combat. So all 3 of these conditions must be true for this to happen. Combat sequence, we display the round number, we count it. It's just an accumulator that's renewed each time we start, another combat sequence with a different antagonist, okay? And we'll either display the heroine attacks the opponent or the opponent attacks the heroine, okay? And then when we do, we'll call the attack method that's built into the base class. The abstract data type we call the entity class, okay? And then we'll call display entity here. And then once we do that, we keep calling this, and if we have a winner, is in this case, the opponent less than or equal to 0, their health, or is the player's health less than or equal to 0? Well, based on that, either the heroine defeats the opponent or the opponent defeats the heroine. Based on whose health is not 0, is greater than 0. But when one of them reaches 0, that's it. They've expired, they die, they lose. Okay? So there's a winner, there's a loser. And we also have some extra code to prevent negative values, negative health values. Okay? And then finally we get here, and here we're just deciding, based on what, where they came from, we return them to where they came from. Okay? Well, multiple combat does the same thing, but the exception is this loop here. And in this case, we're going to loop through, and however many objects, 3 dragons, 5 dragons, 10 dragons, whatever, giants, ogres, we pass that entire group in, okay? And we're just, doing something similar, but it's been coded to work with an array or with a list, okay? Game over, man, just displays game over, player has died. And we could come in here later and add some sound and maybe play a little video clip or something, or code a little animation to move a little stick figure across the screen. You could do all sorts of things here, but that's just sort of a placeholder for what happens when the game is over for now. Okay, we're not doing too much. Now we have the mountain market we go to buy things. And up at the top of this method in the class, just an easy way to set the cost of those inventory items. And then if the player has enough money, they can buy those items. Or later we could code an NPC that could walk in and buy those items. Same thing. But if and only if they have enough money, let's go down here. And if they choose, 0, 1, 2, 3, 4, 5, so forth, they can get the grooming brush, or they can get the slingshot or the slingshot pellets. But it's not just that they have to make a valid choice that comes in from that TK entry widget object as a string, but they also have to have enough money to cover it. So if their money is greater than the cost of the slingshot pellets, or if their money is greater than the cost of the slingshot, then and only then can they buy it. And we would set their inventory to true. And then we would also have to subtract that amount of money. All right, so here we are subtracting the cost of the grooming brush from their total amount of money that they have for every item that they buy. And that's just how the store works all the way through. Okay. Resetting the game state for when they start a new game, or if they load a game from a file. We have to be able to initialize things to where they should be, and then load the game state data from the file and set the value of all those game state variables and the class variables, okay, within the game. All right, these are just event handler methods defined under the constructor. So save game. And save game is file access, and it just serializes all the data. So in the save game first, we have to save all the character data. So every single attribute in that class, we sequentially write to a file. And we do that by adding it to an array. And then after we add it to the array, we just write the entire array to the file all at once. We could alternatively loop through and append it to the file, but this is quicker because adding these attributes to an array takes place in memory. There's no file access, there's no I/O, which would be a bottleneck. And then once we write it to an array, writing that entire array to a file will actually be quicker. And so that's why we're using an array here. But alternatively, if you didn't mind the bottleneck, you could also just loop and sequentially write those to a file line by line. But that's my strategy for saving. So I saved all the character attributes here, loaded them or appended them to an array, and saved the entire array to a file. And then after we save all those, the character attributes, we have to also save the game state variables. And so I could save them all in a single file if I wanted, but to make it more verbose and transparent, to hopefully make this a good learning project, I saved them in separate files. And I'm just using the same strategy here for performance reasons. I append all the game state variables to an array, and then I'll write the entire array to the file all at once. Well, when I load the game, I just have to reverse the process, okay? So I have to open a file, and here I'm just going to list the files in the directory where the script is running. These are where the game files have been saved. And I'll list them, and the player can choose them. And if it ends with dd game, that's my custom, Discord's Dungeon file extension, then we'll display it. Okay, display all the files that end with dd game, and then also dd char for the character file. Okay, and then I ask them to enter a value, and then if character to load get value is true, null values not allowed. Well, they have to input the character. Remember I showed you in the example, I had to input the name of the character file that I wanted to load, and then it would load the corresponding game file. All right, so we just want to make sure that it's not null, has to be valid. Okay, and then if so, all right, so the current directory, dd character, the choice, and then the file extension. We're just doing some concatenation here, and we'll open the file. Okay, and then once I do that, I want to take all the data and I'll read it line by line, and then I can close the file. Okay, and then here's what I have to do. I have to instantiate or build a character object based on the field value of whatever class was saved in the file. So if it was alicorn, unicorn, pegasus, princess, pony, I have to instantiate or build a class once I've loaded that value from the file, and then I call the constructor and build that object. Only then can I then assign all the values that I read from the file. Okay, so here we go. And then in this case, I'm just using the subscript index value of the array and going through and loading sequentially all that data that was part of the class into the newly built class object. So basically we're recreating in the game a character object that has all the values that the player chose and the player decided and resulted with from their decisions, their choices, their mistakes in the game. We're just recreating that entire object here sequentially as we index to all these different elements or subscript values in the array. Understand? Okay. Now the game state file. We open the game state file and we're going to do the same thing. We're sequentially going to go through. We have to load and set all these values to be back what they were, when the player saved the game. And then once we've done that, so the navigation buttons were disabled, we'll enable them. And we'll display everything, and that just refreshes all the stats based on that data. And we'll tell the player, look, your game successfully loaded. Okay. Boolish is just a helper method. There's actually one built in to Python, but I just wrote my own, just a quick example to show you. You can write your own helper methods like I did with dramatic pause and text write and text append. In this case, boolish takes a string, and if it's false or true, it'll simply convert that string value to the Boolean false or the Boolean true. Create NPCs. Well, we've got to instantiate or build our NPCs from that class. So we go through, and these are lists of random things that they can say in the game, clues and advice we might offer the player. So they do that in addition to, the player might choose to conversate with an NPC, in which case they'll look at what the player types in and parse the string and say something different based on, a combination of randomness and also context of the string that they type in. And that's how they can sort of converse with their NPCs back and forth. Okay, but these are just random phrases that they say stored in list for each NPC. So NPC 1, NPC 2, NPC 3, and everything's coded to display this very verbosely. so you can see what's going on. You might say, well, Carly, that's crazy. Why is the game, outputting every single thing it does? Well, hopefully it it helps the project to explain itself. All that verbosity will let you see the mechanics and see what's going on and understand how it works. Remember that this is a constructor. Whenever you see or define underscore underscore init underscore underscore, that's the constructor of a class. So all these methods and functions and variables and data members and even instantiated class objects are taking place inside of our RPG GUI class, okay? And usually, not always, but 99.999% of the time, you're always going to take the self attribute, which functions like the this pointer in C++. It points to or lets you access objects defined within the class itself, okay? And then master here, because this is our parent frame object. So window is master. We're just setting that up here. Okay, now this is the code that actually builds and defines our interface. So we'll go through it quickly, but here we're building a menu, all right? So new menu, and then this is for the edit menu, the file menu, the view menu, okay? And then these, all of these would be called, and this is just sort of a placeholder. Right now, these messages will just pop up, based on what they click. If they click the help handler button, the help button or the help menu item, in this case, we'll display help. And this just launches a child window from our parent window and has its own set of event handlers for its own set of widgets and handlers that handle the triggers or the events that take place in those widgets here. That's how you would do a child window. And all this I'm going to go over in much more detail and in shorter videos. Hopefully that will be less than 30 minutes each. And we'll go over this component by component by component. So to try to keep this video less than 2 hours long, right, I'm trying to go through this as quickly as I can just to summarize. But remember, all the code's on GitHub. You can copy the code, load it up in Visual Studio, and go through it and see how everything works, okay? So these are all event handlers. In this case, use, attack, defend, look, hint, go, okay? What happens when they click those buttons? And this is what happens for our navigation buttons. They call navigate action. Our cheat map, again, just launches a child window with a map in it from our parent window. Okay, uses the same basic process that we talked about earlier, but just for a child window. These are event handlers for our inventory list box and our abilities list box. And based on what gets selected and the string variables that we defined way up above, that's how we can equip, allow the player to change inventory items and equip inventory items or de-equip inventory items. Unequip, de-equip, not sure, but all right, so we create the main window, we add all the widgets, labels, and then the main input and output frame section, okay? So in our main window, our parent window, frame main, we add that. And then frame, label frame main output input. And then to that, again, we add, a frame and a scroll bar. And that scroll bar allows us to have text flow. And then we add a text widget into that frame. And that way the scroll bar, we can scroll up and down the text widget. So if there's more text than we can fit in that window, the scroll bar provides a convenient way to go up and down and read that text. Okay. An entry object, and that's the main entry widget that we use for input. Talking with NPCs, choosing what to do, debugging traps and picking up inventory items and whether or not to engage in combat and all kinds of things. We use that single entry widget object, okay? use, attack, defend, look, hint, and go buttons. And there, notice that we've defined their corresponding event handlers with the command attribute, okay? And then here's our frame inventory to show the inventory, and this just uses our list box, okay? So, and we have a label frame for inventory, and we're going to place it on the window, and then we set up a variable. And then this is just defining all of the, the items that can be selected in our list box. And those pop up at first when they start the game, but then this list, which, it's an array, it'll be cleared when they initialize the game. This is just to display it first when they load the screen, sort of like a splash, but when they start a new game, all these disappear. And they have to earn them. They have to find them in the game. Create a new TK list box, and where do we place it? On our TK label frame, okay? Doing the same thing here for abilities. Another label frame, and another list box, and another set. Here's all our abilities. And that displays it first when they load, but that's all erased when they start a new game. And then they have to actually earn or find those items on the map, okay? Current view, and this just sets up the label. So there's a label within a label frame, and what we do is we set the image attribute of that label to display an image. And so it functions sort of like a picture box, okay? We're going to resize the image, anti-alias it, so it looks good, so it's not so blurry from being resized, okay? And then here's where we set that opening image, the wolf, after Discord was displayed, that's where we set it here, okay? But that will change as they build their character, and as they go through the game, that will change, okay? And then here is our navigation. Here's our navigation frame, and then north, south, east, west buttons, our load and save, and new and cheat. And then here's all of our character stats and all the labels where those values are displayed in our interface, okay? Here we create our menu bar. We've already gone through the event handlers, but here's where we're actually building our menu, and then we launch our GUI here and call main loop. Last, let's scroll up and take a look at our class definitions. Our base class, all right, our ADT, abstract data type, from which all the other classes derive, is the entity class. And this has all the data members or attributes that both an antagonist and a player would need. Name, gender, class, health, attack, defense, charisma, level. So all these are data members or variables set. The amount of damage that weapons, do. Inventory items, whether or not they have them. Non-combat inventory items. Magical skills that they can earn or learn in the game. The cheat mode, which just gives them godlike powers and all the inventory items and sets all the abilities to true and maxes them out and gives them basically an unbeatable amount of health. All right, that's in the entity class. Display entity, and this just takes care of displaying that entity information. Display as opponent, in this case that would display the opponent information. Display character just builds up a string and displays all that in the main text widget. And inventory display, and in addition, it would also take care of displaying it inside of those list boxes. So our inventory variable, and then this is equip inventory, so they can select an object and use an object, right? So you can kind of step through the code, and then skill display and then we'll populate this with the ability array, and that's the ability choices that will show up in that list box, and then skill equip if they choose a skill. And I have to speed up because just my cat isn't going to give me much time here. Display all calls display character, inventory display, skill display. You'll want to check these in the code. Go up and look into the parent class. Here's the attack method. So based on what they've equipped from inventory, the items that they've chosen, a weapon they've chosen, and a magic skill, they can leverage both in combat. And it will, some of it's random, some of it's based on combat experience, some of it's based on the weapon that they select, and the magic skill. And then different points are assigned, defense is subtracted. And then we have some child classes that inherit from the parent class. The base class are ADT, and that's antagonist. And then from antagonist itself, chaos agent derives. And then pony derives from game entity. An alicorn from pony. Unicorn from pony. Pegasus from pony, which itself derives from game entity. And princess from alicorn, which derives from pony, which derives from game entity. So there's an inheritance hierarchy, right? And it's inheriting all the code, all the data members, all the methods and functions from the base class all the way up to the great, great, great grandchildren classes. Okay. NPC inherits from game entity, and that's what we build our NPCs with. And these are the methods speak, conversate, and so forth. And then back to our RPG GUI class. So again, I'll go over this later in much more detail. This is a very brief and cursory overview, but you have access to the code on GitHub, so you can download the file and look at it and examine it and see how things work. And I promise you, if you pick this project and make it your own, theme it out the way you want to theme it, you'll have a lot of fun. You'll become obsessed with it. It'll be engrossing. The next thing you know, it might be a year later, and you're still thinking of things you want to add to your game and levels and whatnot. But it will, in a very entertaining way, motivate you and force you to learn a foundation of Python programming to be able to implement and do what you want in the game.